Hello everyone, this is the third video of the topic permutation and combination. In this video, we have discussed many examples of permutation and combination, and there are some questions left for you which you have to try yourself and tell us in comments. So let us start now. There are 6 different flags. Find the number of signals which can be formed using at least 3 flags. So suppose there are flags, and when they are kept in any particular order, they form some signals. Like the flags are A, B, C, D. So it is one of the signal, and D, C, B, A, it is another signal. We have to use at least 3 flags. So whenever there is the word at least in our problem, means we have to divide it in some cases. Say here it is written at least 3, means either we have to use 3 flags, or we can use 4 flags, or we can use 5 flags, or we can use 6 flags. Depending upon the situation, sometimes we subtract these cases from the total, but here we can do it in this way. Using 3 flags, we have to select 3 flags in a specific order from the 6 flags, means we can write 6P3. Similarly, for the 4 flags, we can write 6P4, since we have to select 4 flags from the 6 flags in a specific order. If there is not specific order, we use C, 6C4, but here we have to select in specific order. Similarly, 6P5 and 6P6. In total, on adding these, we will get the number of signals that can be formed. How many words can be formed with the letters of the word daughter when all vowels are together? And the second part is words start and end with the vowel. Here we have a restriction. So whenever we have restriction, we usually make our choice according to the restriction first, then we perform the remaining choice. We count the remaining choice. So all vowels are together. In the word daughter, the vowels are A, U and E, and the remaining letters are D, G, H, T, R. These are the remaining letters. It is given that these 3 letters A, U and E should be together. So we will treat them as one element, means a box. So in total, if we see here, we have 1, 2, 3, 4, 5, 6. 6 elements, 6 distinct objects. So 6P6. These are the possible number of permutations of these 6 elements. But these letters, it is not said that the letters should be in a particular order. So inside the box, it can be like A, E, U, it can be like U, A, E, etc. So the total number of ways in which these 3 letters can be arranged inside the box will also be taken in consideration. So we will multiply it by 3P3. It is equal to 6 factorial multiplied by 3 factorial. Second part is how many words can be formed with the letters of the word daughter when words start and end with a vowel. So in the word daughter, we have 1, 2, 3, 4, 5, 6, 7, 8. In total, we have 8 places. In the first and the last one, we must have a vowel. There are 3 vowels. So indirectly, we have to select 2 vowels in a specific order. So how many in how many ways it can be done? It can be done in 3P 2 ways. Suppose we filled a vowel over here, we filled a vowel over here. So 2 of them are already used. They may be any of the 2. They may be A or E, they may be E or U, or any of the 2 in any specific order. Now since one of the vowel from here will be remaining, and all the consonants in the word order will be remaining. So D, G, H, T, R, 5 and 6. So these 6 letters will be arranged in a particular order in the remaining places. So the total number of permutations possible with this restriction are 3p2 multiplied by 6 factorial, which is equal to 3 factorial over 3 minus 2 factorial multiplied by 6 factorial. In how many ways can 8 men and 4 women can be arranged in a row such that no two women are together? If these numbers are taken in reverse order, suppose in how many, if we ask that in how many ways 4 men and 8 women can be arranged in a row such that no two men are together, so no two women are together, so it is not possible. Why? Because the number of women are more. If we try to do it, we will find that this combination will not be possible. Here possible combination is given in the question. How we approach this question? See, look in this type of questions, in most of the questions of permutation and combination, first we have to build a logic that how we are going to make our choices. How we are going to make our choices. If this logic is working, is counting all the possibilities and none of them are repeated, then our logic is correct, and then on the basis of this logic and our choices, we can count the number of ways. So if your logic is different, maybe your solution will be different, but you will reach the same answer if your logic is correct. So what we will do here? So first we will arrange 8 men in a specific order. So 1, 2, 3, 4, 5, 6, 7 and 8, and in between men we will arrange women. One woman maybe in the right, one maybe in the left. There cannot be two women in the left. Why? Because in that case they will be together. So in this way we will do the question. So choice number 1 that we have to make is to arrange the men in a specific order. For the arrangement of men, we can choose any specific arrangement. Then we will make a second choice that in these places which we have drawn over here, we will have to select any 4 places. That will be our second choice. And then in the third choice we will decide a specific order of the women. So for the choice number 1, we have 8 factorial ways in which we can arrange the men in a specific order. Then for the second choice, here we have 1, 2, 3, 4, 5, 6, 7, 8, 9 places. So from these 9 we will select 4 places for the arrangement of women. Now in that 4 places we can arrange the women in 4 factorial ways. So this is the answer. Find the number of words meaningful or meaningless which can be formed by the letters of the word again. If we write these words in a dictionary order, find its 50th word. In the word again, we have 2 A's over here, means an object is repeated. So in total we have 1, 2, 3, 4, 5 objects in which 2 are same. So in the numerator we will write 5 factorial and in the denominator we will write 2 factorial. So these are the total number of words which can be formed. These are the total number of words. Our first part is done. Now for the second part we have to find the word which is on the 50th rank. So which word is on the first rank? Let us see. We have, for this we have to arrange them in a specific in a ascending order, like A, B, C, D, E, F, G, H, I, J, K, L, M, N. Its rank will be 1 in the dictionary order. Okay, now if we perform all the permutations of these 5 total letters, then we will reach the rank 5 factorial over 2 factorial. This value over here is 120 over 2, which is equal to 60. So we will reach the rank 60, means we don't have to perform the permutation of all letters, we have to perform the permutation of these 4 letters. After performing all the permutations of these letters, if we have to proceed, then we will have to change the value of this first letter, and in its place we will have to put a letter of just one more value. So here for just one more value we have G. So after all the permutations of these last 4 letters, we will write G in the first place and remaining in the ascending order. Its rank will be 1 plus all the permutations which we have performed. How many permutations are possible with these last 4 letters? It is 4 factorial, which is 25 now. Okay. Oh, sorry. Here it is double A. Great. So we have reached the rank 25. Again, after we perform all the permutations of these last 4 letters, we will have to increase the value of this G, and this time I will come on its place. So here we will have I and remaining in the ascending order. So I, A, G, then end. Its rank will be 25 plus all the permutations of these 4 letters, 4 factorial over 2. Why? Because this time 2 A's are repeated here. So this is equal to 25 plus 12 means 37. Again we will do same thing. After all the permutations of these 4, N will come on the place of I. So we will have N, A, G, I, and its rank will be 37 plus 4 factorial over 2 factorial, and this will be equal to 49. Now if we performed all the permutations and try, actually this N is the largest, so there is if we perform all the permutations of these last 4 letters, we will reach our last letter. So this will we will not do it here, and if we perform permutations of only these 3, then G will come in front. But you can see that for permutation of these 3 are 6 factorial, we will cross our rank. We have to look at just next word. So for the just next word, permutation of this last place means only one case is over here. So after this one case, the value of this G will be changed and I will come in its place. So NAAIG is our 50th word. Three boys and 3 girls are to be seated around a round table in a circle. Among them, a boy, Ajay, does not want any girl neighbor, and a girl, Suman, does not want any boy neighbor. How many such arrangements are possible? Suppose these are the seats on the round table. It is a case of circular permutation. So in this case, we can fix one of our object or one of the given person in the question. First we apply the restriction and then we make the remaining choices. So let in the first place let Ajay will be somewhere, so let's get Ajay be seated on this place. Now make remaining choices for this particular restriction. Here on this place no girl can be there, and on this place no girl can be there. So for here we have 2 choices for boy number 2, and here we have only one choice will be remaining if we place any of the boy over here. So how many boys can be placed here? There are 2 choices. In how many ways the boy can be placed here? We have 2 choices. Now we have Ajay over here and a boy over here and the third boy over here. Okay, now on what place we can have Suman be seated? Only on this place, because if Suman is on this place, there will be a boy neighbor, and if Suman is on this place, there will be a boy neighbor. So only this is the possible place, means only one choice we have for Suman. Now similarly there we have 2 choices for remaining girls multiplied by 2, so in total we can do it in 4 ways. simplify this expression. Here we will use Pascal's rule. NCR plus NCR minus 1 is equal to n plus 1 CR. So these two n should be same and we given increment, and here there should be a difference in R and we choose the larger one. So we will apply this concept here. Here we have 47 and difference of 1 in 4 and 3. So the sum of this part is given increment in 47, it is 48, and select the larger one, that is 4. So 48C 4 plus 48C3 plus 49C3 plus 50C3 plus 51C3. Here again, on adding these two terms, we can get 49C4. Here 48 and 48 are same, and there is a difference in 4 and 3. There is a difference of 1 in 4 and 3. So we take the larger value, that is 4, and here given increment in 48, that is 49. Now we have 49C3 plus 50C3 plus 51C3. On adding these two, we have 50C4 plus 50C3 plus 51C3. In the similar way, we can proceed. There are 4 white, 3 black and 3 red balls. Find the number of ways of selecting 3 balls such that at least 1 black ball must be there. Since there must be at least 1 black ball, here again we have word at least, so there is possibility that we have 1 black ball or we have 2 black balls or we have 3 black balls. If we have 3 black balls, means our requirement of selecting 3 balls is completed. So if there are 3 black balls, means we have just done our job. Now if there are 2 black balls, then what choice we have to make? We have to select any one of the black ball from either this part or this part. So the ball may be white or it may be red. Now sometimes a confusion occurs that since we have to select a ball from the remaining 7, so there are 7 choices which we have, but this is not so. Actually here these 4 white balls are the identical element. In the example we had discussed in the very beginning that if the object, suppose there are 10 red balls and we have to select any 5 balls out of these 10 red balls. So how many ways are there? There is only one way. Okay, there is only one way. Why? Because the objects are identical. Any type of any different combination of 5 balls will be treated as same. So here also, if we have we just differ the balls by colors. If there are two black balls here, so the third ball may be either white or red. So we have 2 choices. Okay, now if there is one black ball, exactly one black ball, so the remaining 2 balls can be both balls can be white, both balls can be red, or one ball may be white and another ball may be red. So in total we have 3 choices for when exactly one ball is black. So in total there are 6 ways. Find the number of words formed containing 4 letters taken from the letters of the word in effective. In the word ineffective, we have 3 E's, we have 2 I's, and we have 2 F's. Then we have a N, then we have a C, a T, and a V. Okay, so we will solve the problem with the help of multi polynomial expansion. Okay, so suppose for some time, suppose we don't have to find permutations, we have to find combinations. So what can we do from this first part, if we either select these two E, or we select these two E, or we select these two E's, all the cases will be treated as same. Okay, wait, let us write 1 plus x squared plus x cube. I will just explain why I am writing this. From this part, for this part, write 1 plus x square. Observe that there were two i's, so I have written 2 over here. For this part, write 1 plus x square. For this part, write 1 plus x. For here, write 1 plus x. Why? Because the c can be selected or cannot be selected, so x to the power 0 or x to the power 1. T is also not repeated, so for 1 plus x, or for all the non-repeated elements, we have 1 plus x. Okay, now suppose we have to find the coefficient of 4, coefficient of x raised to the power 4. If we find the coefficient of x raised to the power 4, what we will obtain? Look, from the first part, we will obtain a pattern something like this. From the first part, for the coefficient of x raised to the power 4, from if this part x square is multiplied in x, and then it is multiplied in 1, then in 1, then in 1, then again in x, and then again in 1. Okay, so in this way we can have one of the term which will contribute in the coefficient of x raised to the power 4. So here we will have x square, then multiplied by x, then 1, 1, then 1, then 1, 1, and in this way here also x. So we will find one of the term which will contribute in x raised to the power 4. In another way we can do it like this one, this x, then this x, then this x, this x. Here we have 4x, then again rest of the ones. From this way also we will obtain a term which will contribute in the coefficient of x raised to the power 4. So indirectly what we are doing, we can select 2 e's from this part, then 1 e from this part, then 1 f from this part, then 1 n from this part, and then nothing, or 2 e's or 1, and in this way different type of combinations are possible. So this coefficient is gonna tell us all the possible type of pairs in which in such a way that sorry, let's repeat the sentence. This coefficient will tell us the number of ways in which 4 letters can be selected from the word ineffective. Okay, now if we have to find the permutation, so what we usually do, if suppose here we have EETV, this one is selected, so the permutation are 4 factorial over 2 factorial, means we have to divide them and then multiply them by 4 factorial, means the number of letters selected, and then divide them by the number of letters repeated. So here also we will multiply it by 4 factorial, and depending upon which letter is going to repeat, we will have to divide them by respective factorial. Now if in this term we find the coefficient of x raised to the power 4, then we will obtain the corresponding answer. So tell this in comments that what coefficient of x raised to the power 4 you obtain from here. From a class of 15 students, 10 are to be chosen. There are 3 students who decide that either all of them will get selected or none of them will get selected. In how many ways they can be chosen? In the question it is written that either 3 of them will be selected or none of them will be selected. So we have to divide the question into 2 cases, and there are 15 boys and we have selected those 3 boys. Those 3 boys are selected, B2 and B3, and a part in which those 3 boys are not selected. We have not selected those 3 boys, B1, B2 and B3. In this first case, since 3 boys are selected, so we have already chosen 3. Now for the 10 we need 7 more. So and since from these 3 are already chosen, so we have remaining 12. From these 12 we have to select any 7. So how many possibilities are there? In how many ways this can be done? This can be done in 12c 7 ways. In this case, these 3 should not be chosen, but we have to choose any 10 from the remaining 12. So from the remaining 12 we have to choose any 10 in this part. So in total we can do the required task in the question in 12c7 plus 12c 10 ways. How many 10-digit numbers can be formed using digits 2 and 3? We have 10 places for the 10-digit number. In the first place, we can use 2 or 3. In the second place, we can use 2 or 3. In the third place, we can use 2 or 3. So for every place, we have 2 choices. We can do this in 2 raised to the power 10 ways. Find the number of ways in which a score of 10 can be made from a throw by 3 persons, each throwing a single die once. So in this problem, we will use multinomial expansion. A die can make a score of 1 or 2 or 3 or so on up to x raised to the up to 6. So we are using x raised to the power 1, 2, 3, 4 and 5 and 6, and that's why we are not writing x raised to the power 0, that is 1 over here. Similarly, second die can make a score between 1 to 6, and similarly the third die can also make these scores. Now from here we have to find the coefficient of x raised to the power 10 in its expansion. So why we have to find the coefficient of x raised to the power 10? Because if we are making a score something like 1 plus 4 plus 5, this is equal to 10. This can be made by multiplying this x raised to the power 1 with the x raised to the power 4 and then with x raised to the power 5 somewhere over here. So this problem is equivalent to asking the coefficient of x raised to the power 10. This explanation is given 1 or 2 times in these videos. So okay, so let's find the coefficient of x raised to the power 10. This expression is equal to x square plus 2x cube plus 3x raised to the power 4 plus 4x raised to the power 5 plus 6x raised to the power plus 5 x raised to the power 6 plus 6 x raised to the power 7 and then again 5 x raised to the power 6 6 8 plus 4 x raised to the power 9 plus 3 x raised to the power 10 and so on. We are not interested in powers more than 10. Then x plus x square multiplied by and so on. So here coefficient of x raised to the power 10 is equal to 4. Look, when we will multiply this x raised to the power 9 with this x, we will get 4. When we will multiply this 5 with this x square, we will get 5. When we will multiply this x raised to the power 7 with the term of x cube here, we will get 6, and in this way we will continue up to this 3. So we can write 3 plus 4 plus 5 plus 6 plus 5 plus 4, and this is equal to this 6 and 4 are making 10, this 5 and 5 are making 10, and this 7. So it is equal to 27. So these were some of the examples of permutations and combinations. Tell us in comments if you need more solved examples on this topic. As you have seen that some of the questions are left for you to solve, so try them out and tell us their answers in comments. Give us your feedback on this series. Share this series with your friends. If we get a better response from you, we will upload the videos of this series more frequently. If you are new on our channel, then subscribe to it and press the bell icon to get the notifications. Thanks for watching.